This is lesson 6.3 out of our Decimals and Fractions book. If you're in Mrs. Walker's class, these notes will be on page 54. And lesson 6.3 is titled Areas of Composite Figures. And composite means things joined together. So it's going to be finding area of different figures that are all joined together, and how can we make that happen. So start with a warm-up. And the warm-up has two problems. Problem number 1 says, find the area of a rectangle with a length of 5 inches and a width of 3 inches. Okay, and number 2 says the area of a rectangle. The area of a rectangle is 12 square meters. The length is 6 meters. What is the width? All right, so those are the two warm-up problems. Let's go ahead and get our I can statement written down. What is our objective for this lesson? Hold on a second. Pencil going? All right. Oh. There we go. Okay. I can find the area of composite figures. Looks like it just repeats our title. Composite figures. That's what you'll be able to do by the end of this lesson. Find the area of composite figures. So I'll get my dark green pencil, underline here, signifying I'm done with warm-up and ready to get started on the notes portion. Alright, so starting out with our notes cut out here and putting it in the upper left space, our normal spot. That was a little too much. There we go. All right. Over here. And we'll talk about what's on the notes sheet. Okay, so vocabulary. It's talking about what are composite figures. Well, they define it here as figures which are made up of 2 or more geometric shapes. So, for example, they have this shape right here, and if it didn't have these dotted lines here, you might think you wouldn't know how to find the area of it. So it's a matter of being able to tell, well, what are the shapes in this composite that I do know how to find the area of? And you do know how to find the area of a rectangle, and you do know how to find the area of triangles. So if you took this composite figure and you broke it apart into this triangle plus the area of this rectangle plus the area of this triangle, then you would in fact have the area of this entire composite figure. So plus and plus. when finding total area. When finding total area. So I'm going to take my blue highlighter and just make that stand out a little bit more. We're adding together the area of shapes we do know how to find the area of in order to get the total area of a composite figure. Okay? All right, now, sometimes we add together shapes we know, like we're doing here, but sometimes it'll say something like, what is the area of the shaded area of this composite figure? So in order to do that, you have to figure out, well, what is the area of this big square here total? And then subtract from it the area that is not shaded in the middle. So they show you here. You take the area of the big shaded square and subtract from it the area that's not shaded in the middle. And when you do that, you would then have the area of just the shaded area of this composite up here. So, when finding shaded areas. When finding shaded areas. Okay, so it's adding when you're finding the total area, and it's subtracting when you're finding just shaded areas. Can't really see that that's a minus sign in there and plus signs over here, but when you do this in class, you'll be able to see that. All right, let's see. Let's take my yellow and get this highlighted, our vocabulary. And what's the vocabulary we're talking about? Composite figures. What does that mean? All right, so those are the two different types of composite figures we'll be working on. The types where we break them apart and add them together, and the type when we find out the total and subtract out what's not shaded. So we'll do examples of both of these so you can see how it works. There's a lot of different kinds of composite shapes you'll be looking at, but the basic steps for how we do each shape is pretty much the same. Okay, so I'm going to draw a little composite figure here. We'll start with one right here that looks like this, and this, and that, and that. And then I'll highlight it with my dark blue pencil. Is that dark blue? That's that purple one. Okay, dark blue. So here's the perimeter of this trapezoid here. Okay, now I don't necessarily know how to find the area of a trapezoid, but I do know how to break this into parts that I can find the area of and then add them all together. So I am telling you that I can put a little dotted line here and make a triangle, and another triangle that's exactly the same over here, and that the height of this triangle is 6 inches, and that the base of this triangle is 3 inches. And the measurement between the two dotted lines that I gave you is 8 inches. This triangle is the same, so it also has a base of 3 inches. So if you saw a composite that looked like that, you could break it apart into a triangle plus a rectangle plus a triangle plus. And if you found the area of all of these three shapes and then added them, what the area is of these three shapes together, then you would have the total area of this composite figure. All right, so that's what we're going to be doing. So over here, I'm going to write area of just the rectangle portion. Okay, I'm going to start with that, just the rectangle portion. It's the area of that rectangle portion. Well, we always start by writing the formula. area equals length times width. All right, well, we know the area of this rectangle is 8 inches. So we got 8 inches, and the height of the rectangle is this 6 inches here. So times 6. So the area is 48 inches squared. Okay, so I'm going to put just my regular pencil circle around that, not a red, because that's not my final answer. But that's the area of just the rectangular portion of that composite. Now, I need to find out what the area of one of these triangles is. So that's what I'm going to do next. So now I'm going to have area. I need to write my formula. Area equals 1/2 times base times height. And what I'm trying to find now is these two triangles. Area of those two triangles. Okay? All right, so 1/2 times base. Well, the base of one of these triangles is 3 inches, and the height of one of the triangles is 6 inches. So I have 1/2. Whoops, I didn't really need to do that again. Well, yeah, I do. Okay, all right. So I have 1/2 times, what's 3 times 6? 18. And what's 1/2 of 18? Easy. 9. Okay, 9 inches squared. Okay, and I'm going to circle that. Okay, but here's the thing. I have two of those, two of the triangles, correct? So I need this 9 inches squared times 2. So that equals 18 inches squared. So I'm going to cross this out and pencil circle that. Now that is the measurement of the area of both of those triangles. So now if I add the area of the rectangle plus the area of the two triangles, I will have the total area of this composite figure. So I'm going to put 48 over here. That was the area of my rectangle. I'm going to put 18 here. That was the area of both of my triangles. And I'm going to add them. And I get 8 plus 8 is 16, carry 1, 4, 5, 6, 66 inches squared. Okay, now that I am going to circle in red because that is the answer to what is the area of this composite figure. All right, and I'm going to take my pencil here. Where did this 48 come from? That came from the area of the rectangle. Where did this 18 come from? That came from the area of my two triangles, right? And that's how you would find the area of that composite. All right, I'm going to take my light green pencil and separate this problem out from the next one that I'm going to do. Okay? All right, so let's see. Next one is going to look... Oh, was I out of frame there? Oh, I hope I wasn't too far. Okay, here we go. All right, next one's going to be a big rectangle. But we're going to talk about what we do when it asks for finding the shaded area. Okay, so it's going to look like this. Rectangle. This is a real common looking one you'll see in these kind of problems. And I'm going to mark about the center of this figure here. And about the center between the two up here. Center between the two up here. Alright, so connect here, connect here, connect here, connect here. Now I'm going to trace that over with my blue pencil. Okay, and then the shaded area is going to be this area in here. So I need to find the area of just the shaded area of this composite figure. So I better get my black pencil and write that down. Find shaded area. And remember, when we talked up here, when we're doing find the shaded area, it involves finding the area of a total shape subtracted by the area that is not shaded. Okay? So what we're doing here is taking this entire, the area of this entire rectangle and subtracting from it these unshaded triangles. So we'll be subtracting from it 2 unshaded triangles. When we do that, then we'll have only what's left over is only the shaded area. So the big shaded subtracted by the 2 triangles that are not shaded leaves us with shaded. Okay. All right, so the area of the shaded rectangle is what we will find first. Okay, well, we need some measurements there. So the height of this rectangle is 7 8/10 centimeter, and the width of the base of these triangles, which are both the same, is 13 centimeters. All right. So to find the area of the total rectangle, we first write our formula. A equals length times width. And I have 7. Well, let's see. Let's do this first. 13 and 13 is easy to add. So 13 plus 13 is 26 times 7.8. 7.8. Okay. 26 times 7.8. Well, I'm going to have to do some scratching off to the side because I don't know what that is right away. Right? So let's do that. Let's see. 4, 5, 7, 8.8. And add them up. And we get, okay. All right, so 26 times 7 8/10 is 202 8/10 centimeters squared. All right, and I'm just going to pencil circle that one because that's not our final answer. That's just the area of this whole rectangle. All right, so now over here I'm going to work out the area of one of those triangles, which are not shaded. All right, so area equals 1/2 times base times height. 1/2, the base of one is 13. The height of one is 7 8/10. Right? So now I'm going to convert that 1/2 to a 0.5 and figure out what 13 times 7.8 is. So I'm going to have to scratch out to the side. Hang on a second here. All right. 0.5. Okay, 5/10 times, no, I'm just doing 13 times 7/8. Hold on. 13 times 7 8/10 is 101 4/10. All right, now I got to do the math. 101 4/10 times 5/10. So hang on. And I get 50 7/10 centimeter squared. All right, which makes sense because multiplying this by 5/10 means what is 1/2 of this, and that looks to be reasonable. Now I need to multiply this, however, times 2 because there are two of those triangles. So that times 2 gets us back up to what we were here, huh? Why does this lead keep breaking? I got bad lead. All right, so 101 4/10 centimeters squared. So pencil circle that. All right, now I know what is the area of the 2 triangles that are not shaded and the area of the entire rectangle. So now what I have to do to get a total answer is subtract the unshaded triangles from the rectangle. So over here I've got 202.8 minus 101.4, and that gets me 4101. So I hope I did this right. How many times do you guys hear me say that? Because it's back to that. Oh yeah, I guess that would make sense. All right. So the total of the shaded area only on this composite figure, the total of the shaded area only is 101, let me say that right, 101 and 4/10 of a centimeter squared. All right, so I'm going to take my light green pencil and give a little draw down here so I can show you one other one over here. So this is a pretty common one that you'll see that looks more complicated than it is, so we'll talk about it. So I've got a square here. And in my square, I have another square twisted, kind of like a diamond. And inside that, I have another square back the other direction. And the parts that are shaded are this outside part and the very center square. And here are the measurements that oh yeah, we're not going to actually find it. I just want to show you the thinking process. So it looks complicated. How would I find, what is the shaded area of that composite figure? Well, what you need to be thinking about is that you have the large square first, find the area of it, minus the smaller diamond in the middle, okay, and then add back in that shaded square in the very center, right? So you're thinking, I need the area of the total shape minus this area that's not shaded, plus the area in the very center that is shaded. All right? So I'm going to write down here some notes. It's total minus unshaded, add back shaded middle square. Okay, so we looked at these notes here, and they talked to you about how often you just break it apart and add it up. Sometimes you find out the total and subtract something else so that you can find out what's shaded. Well, sometimes when there's multiple composites within them, like this, you find the total, you subtract something in the middle and add back in another piece. So it's a matter of being able to see the pieces that you can pull apart so that you can find the area. Okay, so let's take a look at lesson 6.3 practice problems. There's 3 practice problems on this one, and all of them have the directions of find the area of the shaded area. And so number 1 is this composite figure right here with its measurements. Number 2 is this triangular composite figure. And the last one is this composite figure here. So remember your steps for making these happen. Go ahead and put it on pause, and then I'll show you how they work. Okay, so problem number 1. I have a figure here that I can break into 2 different rectangles, and there's more than one way you could do it. You could go across here, or you could could go down here and figure out your measurements either way. I think I'm gonna go across. So if I make a dotted line right across here and treat those two this composite figure as these two rectangles and then add them up, then I'll have the area of the total composite figure. So I'm going to do this smaller one up here first. Draw this little figure here. Area equals length times width, and the length on that rectangle is 4 inches. Times the height of 2 inches, or width of 2 inches, and so so the area of that is 8 inches square. Okay, now the longer one, again, area equals length times width, and the length is 9 inches, and the width is 1.5 inches. All right, now I can't multiply with that mixed number like that. I got to turn it into an improper fraction. So I'm going to do 9 over 1 times 3 over 2. All right, there isn't any way I can cross multiply this, or cross reduce or cross simplify, however you like. So now I need to multiply across. 9 times 3 9 times 3 is 27. 1 times 2 is 2. And 2 goes into 27 13 times with 1 left over. So we've got 13.5 inches squared for the longer portion of my composite. All right, so now I need to take this figure and this figure and add them up. So 13 plus 8 is 21, so we've got 21.5 inches squared is the final answer for this first composite figure. And I'll circle that in red. Okay, now for the next one, our triangles. First I have to find the area of the outside, the large triangle, to find the shaded area on this one. So area equals, and this is in meters, this is in a decimal, so I'm going to go ahead and just put now, oh sorry, I guess I better keep the, we'll change it on the next line. Okay, area equals 1/2 times base times height. Alright, so I'm going to convert that 1/2 to 0.5. The base is 12 meters and the height is 11 meters. So I'm going to go ahead and multiply my two whole numbers. I'll bring this down. 12 times 11 is 132. And now multiplying 5/10 times 132 is the same thing as saying what is half of 132. And half of 132 is 66. So the large shaded triangle here is 66 inches squared. Now I've got to figure out the area of this unshaded smaller triangle. So again, I have area equals 1/2 times base times height. Now I'll convert that 1/2 to 5/10 times the base is this 4 inches here. Don't get confused that I'm calling this top line a base. I know you're used to seeing it as the bottom of a triangle, but no matter which way we rotate this triangle, I know this is the base because of the little tiny square here that tells me this is a right angle, and so that's going to be my base. But it doesn't really matter, right? Because we're multiplying, so order doesn't matter. But I'm just trying to be good and proper here. It might be a little difficult to see, but the height of my triangle here is 3 5/10, 3.5. So I'm going to put that right here. Then I'm going to multiply my two decimal numbers over here, carry down this 5/10. So 4 times 3 5/10 is 14. Nice whole number, which makes it easy because multiplying 5/10 times 14 is the same thing as saying what is half of 14, and half of 14 is 7. All All right, now we're trying to find what the area is of the shaded area, so we need to subtract out this unshaded area. So over here, I'm just gonna put the 7 right underneath there. Okay, let's do our math. 66 minus 7 is 59, and this is meters squared. So 59 meters squared is the answer for the shaded area of that triangle. All right, so this last one's pretty easy. It's fairly similar to the top one we did. So we have a composite figure, but it's been broken down into this rectangle and a triangle. So the easy part is to go ahead and figure out what we've got for area on that rectangle. So the rectangle, let's see, area equals length times width. The length is 8, not 10, because 10 would include the base on this triangle. The length is 8. Length is 8 times 4 is the width, and 8 times 4 is 32. So 32 inches squared, and I'll give that a little pencil circle on that. Now I got to figure out the area of the triangular piece of the composite. So area equals 1/2 times base times height. Okay, now on this one, it doesn't label for me what the base is, but I can figure it out because I know this entire line is 10 inches and this part of the line is 8. So if I subtract the 8 from the 10, I'm going to be left with 2 inches at the base of that triangle. And the height of the triangle is the same as the height of the rectangle. So that's going to be 4. So I do my whole numbers first. 2 times 4 is 8. And 1/2 of 8 is 4. All right, so 4 inches squared is the area of the triangular part of the composite. Now I want to know what the area is of this entire composite, so I need to add those two things together. So I'll just put 4 under here. 4 plus 2 is 6. 36. Oops, why did I write 2? 36. All right, so my answer is 36 inches squared. That's the total area of this composite on problem number 3. Okay, all right, so that is the practice problems for lesson 6.3. Now let's take a quick look at our worksheet. The worksheet has all kinds of different figures, but they're broken apart, very similar to what we've already seen. The thing that I want to point out here is that on problems number 1, 2, and 3, it says use a diagram or words to explain how to find the area of each shaded area. Now you can use words and describe it, or you can use a diagram, and I'll show you what they mean on that. They're not asking you to find the area of the shaded regions. They haven't given you any measurements here, have they? They just want to know, do you understand how you would go about doing it? And you do, because we covered that here. Remember when I, well, both on the little notes card, but when I showed you here how we took it apart and I made this little figure plus this figure plus this figure, or down here it was this minus this, or down here this plus minus this plus this. That's what they're asking you to do in these. What would you add and subtract? What shapes? How would you break it apart? What would you add and subtract to if you did have to find the area of the shaded region? Okay, so now when you get down to this part, they really are asking you to find the area of each of these figures. And this is a lot like we did in the practice problems, where you can do this more than one way depending upon how you want to break it up. Okay, it's up to you. And so you might want to study it a little bit and see what's going to be the easiest with the information that they give you. Okay? Then when we get down to here, these are the ones that again, study your notes, and you'll know how to work them out, and you'll know how to do the shapes. So you've got everything you need in your notes or the practice problems to make this worksheet happen. Okay, so last thing is the exit ticket. The exit ticket is just one problem, but there's a lot of steps in this problem, which is why it's only one problem. So exit ticket for lesson 6.3. I'll leave that there for a second. Okay, so that's lesson 6.3. Remember, the only way to learn math is to do math, and mistakes are proof that you're learning.